This is a detailed version of how to create P chart using Excel, and we are going to compare the result using many tab software also as well. So this is what you can get it. You can get the control limit. When you say control chart is all about control limits, right? You will get that one, and then you will also will learn how to calculate what's the formula and so on. In the past video, we talked about the U chart. The U chart has a formula called U bar plus 3 root of square root of U bar divided by N. But the P chart has a different formula. Same thing, P bar plus 3 square root of P bar 1 minus P bar divided by N bar. Meaning, whatever the sample you take, that you need to take an average. Let's set the context first. Let me take brand new Excel. So what we are talking about is that, let's say, defective. Anything fully is not usable is defective, right? So in defective, let's say you have two defective, and out of you have tested volume of, let's say, in this example we say bulb, right? So how many bulb been tested? 100. That means how much defect we are talking about? 2%. 2 divided by 100. The same concept, P chart works, right? P gives that how much proportion, for example 2%, 3%, then how much percentage, and then we can have that control limit. That's what it is called, control chart. So now what I'm going to do it is that I'm going to have this header and create the own examples, and then we can take a look. Let's say sample, let's say I'm keeping the sample of 500. 20 samples been taken, or it is been done in 20 days, example, let's assume that. And defective, so in defective what I'm going to do is that I'm gonna say random between 1 to 10, example. I'm just dragging it up, and this will change every time. So what I will do, I will just copy and paste as value. So now this will not change, right? And then P bar. So same simple formula, defect by volume. For example, here in this case, very small percentage, right? And 0.6 percentage, less than 1%, and drag it up. And now here, what I can do is that I can take the average confidently, 0.9 percentage, it should show up. And generally speaking, when you have a different sample, if the denominator are different, then average is not a good method. So what I'm doing it, you can just do this method, like sample of everything, sorry, sample of defect divided by sample of how much sample we are going to test it. So this is going, it shows that it is 18. So something wrong. Wait, let's see. So now we are talking about 0.91, and there is something wrong here. So I have not given some formula here. So just giving open parenthesis, I will close the parenthesis, and now it should match exactly like zero point 0.9, right? So now this has been done. Okay? Technically, what we are saying is that sum of this, right, 20 divided by this value where we are talking about, right? 0.9 percentage we got, but here we can verify this value. Okay? The formula part is in very interesting one, right? This is a formula. You see, I will just keep it in the bigger screen so that it is visible. So P bar, this is our P bar, right? Individual P bar value. This is your individual value. This is a P bar. Bar mean average, like P bar, U bar, X bar R chart, and so on. An LCL, so we can take this plus, I'll start introducing bracket, 3 into square root of 1 minus square root, again I'm gonna go with this one, d2, divided by n. N I will keep it here. I have not determined the n yet. I'll keep it here. give okay. Right. Okay, give okay. And here n you can see here. So this is n has n bar, right? So n bar is nothing but average. So here average of 500 is, of course, 500 is an average, right? So now we got this percentage, right? So now G2 and D2 is going to be dynamic. So I mean is constant. So I'm gonna give absolute reference by pressing F4. So now it has been done. So I will drag this up. So this has been ready. So I will convert back to percentage and just control percentage P. You can just control. So now 1.5 percentage is our upper control limit. The same thing we can do here. The only thing is that we're gonna apply minus because the same formula, ditto same formula, only we're going to apply minus. So here 0.3 percentage is fine. If supposingly if you're getting it in the previous example, the actual value we are getting it is, let's say I'm just removing it if condition here. So it is 0, right? So in this case, this is fine, right? Even if you're getting the minus value, you need to convert back to positive value as it. That's one of the small thumb rule as it, right? So now we've got this value. Now we don't need this formula. We can delete. Okay. Now what I'm going to do it, I'm going to drop the control chart. So the third one, so just give here. Okay, I'll give a title. P chart for lamp defectives or scrap or whatever. And now the interesting part is that I don't need the grid lines, and this is in all the same value, right? So now what I will do, I will just click on the last cell. I will just give here, and then I will just click here. I will just call out this value also. Or you can either you can drag this up using that mouse, or you can just, maybe I'll show you this one, or you can just right click format and then you can below or above or whatever you can do. So anything which works best for you. So it's now what I'm doing it, I'm just all these values I'll just call out a bit with the bigger font, 3 or 12 example, and this one is 12 again. This one will keep it. Yeah. So now, sorry. Now you see that this also we have done. Now let's compare that value here, right? So maybe one thing I will do it is that I will, this color I will change it, because in rejection we say green, higher the percentage is not good, right? So I'm going to keep it red. Here I will give blue, and here I will keep it the same color as it. So now this is the one, and then I can also see here. So now you see that so there are outliers. I mean, when it comes to rejection, outlier should not be on the upper side, whereas the lower side it can be there, right? So no problem. But upper side it is, and there are outliers, right? So let's see the same result using Excel. Whether Excel gives the same result or not, we can find out. So what I'm doing it, I'm just taking new, I'm going to menu tab, MINITAB. I'm going to open menu tab and paste it here. Now you see that I don't need all of these value, right? So wait, go back, I'll just copy this value because menu tab will calculate everything. Go to stat, go to post control chart, and go to attribute chart and P chart. Right? And so this is defective lamp divided by sample size. This is great. Now how much you are getting it? 0.91, exactly the same value. 1. Now here we are getting a different value, right? So let's see 2.1. Is the value being pasted properly? The last value is 6, yes. And let's see why it is not taking that value. I think there is something wrong with the formula. So it says 0 and then 2.1. So let's go back and check the formula again. So this we are talking about defect and divided by this one. This is correct. And then LCL. So the formula was, let's take that formula again. This is also good experience, learning experience, right? So P bar, that is 0.91, that is D, plus 3 into, okay, so 3 into, it is taking this as a, okay, 3 square root of 1. Oh, P bar we are missing it. P bar we are missing it. Okay, so, okay, and D2 1 minus, okay, so here we need to keep it bracket. We have applied the, we have missed P bar here. I think that could be probable reason. And good that we have discovered that. Okay, okay, 2.2 percentage. And what I'm gonna do is that D, we need it as an absolute reference. I will give a 4. Enter here 2.2 percentage. Click here, and the same formula I will copy and paste it here. The only thing is that I'm gonna give minus here. Okay, this is exactly what I was saying. The the rejection cannot be minus. So what I will do, I have to give one more instruction. If this value found to be minus 0, right, then return as plus 0, right, plus 0. Okay, and just dragging it up. Now, okay, so let's go back. So sorry, we missed that P bar. So one more time, we'll go through the formula. This is the formula. So P bar, 3 times P is coming on the numerator. In denominator, there is no P. So P bar plus 3 square root of P bar, 1 minus P bar divided by N bar. So now we'll compare this result. So 2.18, 2.184. Let's see whether we are getting 2.184. Let's, exactly, we are getting the same. And 9.1 we have got, and then we have got 0. Exactly the same value we have got, right? Very, very same value we have got. And you can see this is how we can create this one. So what is the beauty is that even if I do that changes here, let's say I'm just making it 1000. So the graph will get updated automatically. You can see the graph has been updated even in many tab. So what I will do, I will make it 1000, and I will just go to graph, or I can just copy all this value, go back to graph, just right click, update graph automatically. Now it is updated 1% and 0.4%. Not that, exactly the same value we have got, exactly the same value. So now even if I change this value, right, so I'm just giving random between, and just taking it like 1 to 12 example. Slightly the rejection is up 1 point. Let's say I'm just copying this value because I need to test this value using Minitab. Okay, copy this value. So now we are getting 1.522, right? Let's see whether we are getting 1.522. Paste this value here. Copy this one. Paste it here. And go back to this graph. So now 1.5, exactly the same value, right? Now, one thing we are going to do is that we are going to vary the sample size, right? Completely, we are going to change it. Now that will be tricky, right? In Excel, Excel may not give that accurate value. Sometimes it gives, sometimes most of the time it does not give that accurate value. So let's say my sample every time differs between, let's say 500 to 1000 pieces I take, example, bulk, or my incoming received quantity varies every time. So let's see whether it gives the same value or not, right? So now the average value is 765. Let's say whether we are getting it. So now copy this value, go back here, paste it back here, go back to graph, and then we are getting 1.923, 1.989, not this one. There is a subtle small changes is there. So that's what actually when you do that actual value, like for example, even if I do that, interchangeably, if I do like all the time I'm just saying 500, then I think Excel and will work and it gives the right value, right? For example, 500 across the board, I'm pasting it, and if I test it, it should be the right value. But when you have variable samples, so Excel sometimes does not give the right result. For example, let's say the 3 percentage to 1.4 percentage, right? So it has given. So if I vary it, let's take one more time whether the result is going to be same or not, right? 500 to 1000, right? I'm just dragging it, copying this value and pasting it here. Again, one more time, copy this value, paste back in mini tab. Just go to graph and see 2.2, 2.01. This is not matching. This is not matching, right? So when you have too much variations in the your sample is variable samples you have, right? Then it's not better, not you don't do it. Although you have that formula called n bar, but or even if you take maximum, right? Even if you take maximum, sometimes it works, but most of the time it does not work. But many tab always gives you the exact right answer, right? Example, and this again the value hasn't changed. That's a good thing. Okay, so what I will do, I will copy, paste it here, take this value and go back to mini tab, paste it back, come here and see 2.27. 2.27. No, it's not matching. Not matching, right? Even if you take average, 2.1, right? But here the actual result, Minitab gives very, very accurate and perfect result, and this is not matching. So whenever the only in Excel, when you have, you can frankly and boldly use when you have confidently you can use when you have a sample size almost a constant, you can use it. It will give the same result. Like the example, I'm just testing it here. It should give the same result, 1.522. Let's say I'm just taking it here. I'm just copying again, pasting it here. So now going back, it is exactly, it is giving the same one. The only, this is the only lesson we have in many tab, Excel actually. But in many tab, it doesn't require any calculation. It gives straight away the results, everything. I hope you find it useful. Of course, you can very well do that formatting furthermore, and you will have fine tuning and all that. So dynamically, whenever the changes is there, for example, let's say you can also highlight it. Let's say this cell is going to be changeable. So you can just highlight it so that and all these will automatically calculated. It's a one-time thing. So once it has been done, so your values will get automatically get updated. I hope you find it useful. Thank you so much.